Good evening, madam. My name is S. Nagarjuna. I am studying in Department of Civil Engineering in second year in Srinivasa Ramanujan Institute of Technology. Today, my topic about on discharge curve in open channels. Discharge curve in open channels. A suitable method for analyzing the discharge curve in open channels hydraulic is the specific energy versus discharge relationship, often visualized as a discharge curve or specific energy diagram. This method helps determine flow conditions, identify critical depth, and analysis energy variations. Means in this discharge curve in open channels is where the relationship between the specific energy versus discharge to visualize the discharge curve or specific energy diagram. In this, to determine the flow conditions, identify critical depth, and analyzing energy variations by using of the discharge curve in open channels. Here the diagram for the discharge curve or specific energy curve. In this, they shown the specific energy curve and depths, heights, and inclination. Variation of discharge with specific energy. The specific energy equation for rectangle channel is E is equal to H plus Q square by 2GB square H square. To express discharge as a function of specific energy E, we rearrange the equation Q square is equal to 2GB square H cube E minus H, where the specific energy for the rectangular section is E is equal to H plus Q square by 2GB square H square, where E is equal to energy of the specific energy of the channel, where H is the height of the channel, where Q is equal to discharge, G is equal to gravity, B is equal to breadth of the channel, and H is equal to height of the channel. Where the equation we rearrange, that is Q square is equal to 2G B square H cube E minus H. Taking the square root becomes Q is equal to B root 2G H 3 by 2 root over E minus H. In this, where the Q square on the side of the is equal to, it becomes B root 2G H 3 by 2 root over E minus H. This equation shows that for a given specific energy, that are two possible depths H1 and H2 corresponding to the same discharge, one in the subcritical flow rigami, that is deep and slow, and other one is supercritical rigami, shallow depth. These depths are called alternative depths, where the specific energy equation having two possible depths, that is H1 and H2. In this the same discharge to corresponding the same discharge, one is subcritical flow, that is deep and shallow, and another one is supercritical rigami, that is shallow and fast. These are the depths are called alternative depths. Critical discharge and critical depth. The maximum discharge occurs at a critical depth, which correspond to the minimum specific energy. The condition for critical flow is Fr is equal to V by root 2GH is equal to 1, where the critical depth is to corresponding the specific energy for critical flow. The equation is Fr is equal to V by root GH is equal to 1, where Fr is equal to Froude number, V is equal to velocity of the flow, G is the gravity, H is the height of the channel. Where the equation where the entire equation will become 1. Substituting the V is equal to Q by AB for rectangle channel, where in that A we substitute the B area formula of rectangle channel, that is B into H, breadth into height. Q by BH is equal to root GH. Solve for critical discharges. QC is equal to BHC root GHC. Since CHC is obtained from HC is equal to Q square by G B square whole of 1 by 3rd. The critical discharge equation becomes QC is equal to BHC root over GHC 2 by 3rd ECB root GHC. This is the critical discharge equation for the specific energy curve or discharge curve. Significance in flow regulations. What are the significance in the discharge curve is flow control using weirs and flumes. Structure forces flow to critical conditions to measure the discharge accurately. By using the discharging curve in the critical condition to measure the discharge accurately, Energy consideration in channel design. Engineering adjusts specific energy to control flow speed and prevent erosion. Where in this engineers by using of the specific energy to control the speed of the flow and erosion of the soil. Hydraulic jumps and energy dissipation. The discharge curve helps predict where hydraulic jumps will form from control energy losses. Where in the discharge of the significance is to control the energy losses of the channels and or in hydraulic jumps for control on river engineering. Understanding discharge variations aids in designing spillways flood routing strategies. Thank you, madam.